So you would have heard of the phrase sequentially done. What it basically means is that, for example, if you are cooking something, then you could have A, B, C. You could have these three steps, right? You could first you would have to do A, then you would have to do B, then you would have to do C in order to cook a dish, maybe. But in some cases, you would have to repeat the procedure A before going into the next step B, right? And after doing this, you would have completed a dish, right? But this isn't always the case. You could also have something like A, B, C. All these three are repeated, 3 or 4 times for completing the dish. And uh, it could also be the case that sometimes, not in cooking, but in general, we could have something like A, B, C, 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 and so on, and it goes on and on indefinitely. This is also possible. This could be understood by programmers. They would be familiar with the while loop, where you would do a series of steps until the condition is true, until some condition holds true, and when that condition becomes false, you would come out of the while loop. So this is something like that. Um, this is how we think of a sequence, in day-to-day life. But mathematically, when we talk about sequences, we would talk about similar stuff. But the thing is that mathematically, a sequence is an infinite list. It keeps going on and on. It doesn't stop somewhere like this or this or this. It is like the fourth case that we just looked at. So, for example, we could have a sequence like A, B, A, B, A, B, and so on. Then we could have a sequence like B, 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 and so on, all B's. So, in these two sequences, there's one thing common, that is, we would call this B the first term, we would call A the first term, here we would call this the second term, here this would be called the second term, this would be called the third term, this would be called the third term, and so on. So no matter what sequence we are looking at, we would always call the first term the first term, the second one the second term, and so on. So basically, we can use this property of a sequence to motivate our definition or mathematical definition for a sequence. Basically, a sequence could be thought of as a function from the set of natural numbers to any non-empty set S. Here, the set we are considering has the elements A, B, right? Because only A and B are repeated again and again. Here, the second sequence could be thought of as only having the only having the element B, right? So the set could be thought of as the singleton set containing B, right? So any sequence is basically a function from the set of all natural numbers to any non-empty set S, right? For example, in this first sequence that we considered, f f of 1 would basically be the first term, which is nothing but A. Now f of 2 would be B here, since we have the second term as B, and so on. So this is mathematically how we define a sequence. Now that we have defined a sequence, in a rough way, let us look at some examples to understand better. So let's consider the set to be having the element 1, right? Now we can only construct a sequence like this: 1, 1, 1, 1, and so on. First term here is 1, second term here is 1, third term is 1, fourth is also 1, and so on. But if we consider the set S to be say having the elements 1 and 2, we would have many possibilities. So we would have again 1, 1, 1, 1 as a sequence. We could also have 2, 2, 2, 2, as a sequence. We could also have 1 2 1 2 as a sequence. There are many possibilities that we can see. We could also consider as to be having the elements, arbitrary elements a, b, c, right? Now this leaves us with so many sequences, like we could form a, b, b, a, 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 and so on. So we could form so many sequences with just with this set. Now that we have you know looked at some examples, uh, let us move on to the next step. Let us try to understand how a sequence is using visual tools like graphs. So we have defined a sequence in terms of a function, right? So a function can be graphed on a graph sheet, right? So we can use that to exploit and visually understand how a function is, right? Of course the function should be defined on a set S such that S should contain numbers, right? If the set doesn't contain numbers, then we cannot visualize it on a graph. So now, for example, uh, let's say that we are defining a function, or rather a sequence, uh, on the real line, right? So we are considering real sequences, that is sequences with their terms being real numbers, right? We could a possible sequence would be 1, 1.2, 1.21, 1.3, minus 2.6, 0, and so on. So we could have this sequence. We could have any other sequence like 2, 0, 0, 0, 0, 0, and so on. There are so many possibilities here. So conventionally we would denote the first term of a sequence using the symbol x1, right? X1 denotes the first term of a sequence. First term is also f of 1, as we would know. X2 is the second term, and also is equal to f of 2, and so on. So that's how we notate. And now to graph a sequence, we would consider this axis, the x and y axis, and on the x-axis we would let the natural numbers sit, 1 2 3 4 5 and so on. And on the y-axis, this is where we are going to visualize the points of the sequence, right? For example, we would have 1 2 3 4 and so on. Now uh, let's say that our sequence is 2 3 3 3 and so on. So basically the sequence, in the sequence the first term is 2 and all the other terms are 3. So since we would denote the first term of the sequence by the symbol x1, right? So x1 is basically f of 1, right? And f of 1 is 2 in this case. So in order to visualize this point, we would plot 1 comma 2 here, because the first term is 2. This would denote x1. Then we would have x2. X2 is f of 2, which is basically 3 here. So we would plot a 3 comma we would plot 2 comma 3, right? We would plot 2 comma 3 to denote x2. And similarly we would plot 3 comma 3 to denote x3, 4 comma 3 to denote x4, and so on. So this is the sequence. Now let us plot some other sequence as well. So let's plot the sequence 3 3 3 3. All the terms are 3, right? 1 2 3 4 5, 1 2 3. So the first term x1 is 3, the second term x2 is 3, third term x3 is 3, and so on. So this is the sequence 3 3 3 3. Now let us plot the sequence, let's say 4, 3, 2, 1, 0, 0, 0, 0, and so on. So it starts from 4, it comes to 0 and it stays at 0, right? Okay, so this is 4, 3, 2, 1, 1, 2, 3, 4, 5. So the first term is 4, the second term is 3, the third term is 2, the fourth term is 1, and the fifth term is 2. And if we kind of extend this, we would see that the sixth term is 0, seventh term is 0, eighth term is 0, ninth term is 0, and so on. So this is something like this. This first decreases and then it stays at 0. So this is this sequence. We could have a sequence something like this as well. One, two, three, four, 5, and so on. We would have numbers 1, 2, 3 as well here. X1 would be here, X2 would be here, X3 would be here, X4 would be here, X5 would be here, X6, X7, X8, X9, X10, X11. So this follows a shape like this, right? This is also a valid sequence. So this is X1 here, this is X2 here, and so on.